Good evening, everyone. It's on clean code. So I would like to take a particular phrase like that. Uh, Even bad code can function, but it will bring software organization on its knee. That means you can write a very lengthy program in, let's say, in one particular class, but in one particular file, but it would work fine. But the problem is when it comes to organizations, it is very difficult to one thing to maintain. So when you want to do some modification, so it is very hard. So maintainability is not there. So and when we want to test it, so there are certain difficulties. So those kind of, there are plenty of others. So if that sort of incident happen, what happens is the organization or you will need to go to the customer and say, sorry, so because it will take some time to deliver. So there are gaps in there. And there is one other theory which is called broken window theory. It is like that one broken window is all it takes to start the decline. That means when we are working on a particular system, if we experience a particular error, that means we expect more errors to come because we don't have any confidence on that particular system. So that is one theory. So to get rid of most of those things, what we want to do is we want to write a particular clean code. So when writing clean code, there are certain research conducted by people. So how we can write and deliver a clean code. So I found a particular solution which is given by two German developers. So that is basically from Ralph and Stephen. So that is on Clean Code Developer Initiative, CCD. So I'll walk through it on it, so how the things are in there. So it has a particular model like that. So it basically defines a set of value stream, as you can see here. Set of value streams and set of degrees. So those two are defined. So using the set of value system and degrees, a particular virtue is being achieved, and degrees are discussed in two areas. One is from principle and other one is from practice perspective. So I'll start with the value system, then I'll talk about the degrees, and then I'm talking about how the virtue is achieved from that. And those are the main four value systems that are being talked in that particular initiative. First one is evolvability, and then correctness, production efficiency, and continuous improvement. So let's walk through one by one. First one is evolvability. It is something like that. The software has to be maintained. So you just can't develop in and let it go. So there are a lot of activities happening related to particular software. So main thing, modifications could be happen due to a new requirement introduction, or there could be a particular bug encountering the system. So due to those, maintenance activity will happen. And the important thing is when those maintenance is happening, the internal structure and the internal organization of the system has to support for that particular modification. Otherwise, it will be very difficult to do the modification. For example, if, let's say, in a particular environment, you are sharing a particular method with large number of other functionalities. So what if you want to change that particular function, it will affect all other usages. So that those kind of problems are there. So a system ideally should not be like that. So this is that behavior calls evolvability. So when the evolvability is high in a particular system, cost and the complexity of modification gets lower. So the second value is correctness. Software must be functionally correct. And the correct, checking whether software is correct or not, is not only a part of testing. It is a part of developer. That means the correctness has to be there in the system from the beginning to end. So it is should be in the entire cycle. And a common example has been discussed in that particular initiative. It is like a car has many functionalities, but nowadays when we put our car to a garage, what will happen? So they have very latest devices. They just plug in that and they identify each and every small problem in the car. But software is not like that. So when we identify a particular problem, we need to run on debugging process because it is a very tedious process because there is a big gap between those two. Finding a bug and issue is somewhat difficult, but there are new tools coming into the industry to solve those. And next thing is production efficiency. And efficiency, it is related to cost and cost as well, because software development time and cost play a main role in the system. And inefficient software increase time and cost, and development could extend years, because there are systems which are being extended up to multiple number of years due to that. So they will generate more errors. And within the initiative, they talked about, so rather making a particular inefficient system as an efficient system by correcting their mistakes, it would be more better scrapping out the system and redesigning the entire thing. So that would be one better option, right? And the final one is continuous improvement. That is learning about new things and application of those things in software that we are writing. So that could be achieved in many other ways. We have pair programming, code reviews, daily reflection, the kind of things. So those are the main 4 values that is presented in there. So those values are being used along with set of degrees as we discussed in the initial model. So there are main 7 degrees available starting from 0 to 6. So I'll explain each and every degree. So level 0 is the identification of the requirement for a clean code. So when we have a particular system, most of the people don't understand that the code need to be clear. So identification is a main primary degree. Next one, level 1, it is red. It is a path of clean code developer starts with the red degree. So that is the initial step. Once you identify there is a clean code requirement, level 1 discuss the entry point to clean out the code. So there are principles and practices. As I have explained, each and every degree has a set of principles and practices. So level 1 has a set of principles like that. First principle is don't repeat yourself. What does that mean? In code, if you are from academic background, I have seen a lot of people are doing copying the code and pasting it in other place, rather using a particular common code across other places. So that is called duplication of code. So that is the first one principle identified in that level. Second one, keep it simple, stupid. So making it simple is very important, because a lot of people try to put design patterns. So what is a design pattern? Design pattern is a common solution for a known problem. It has been invented by somebody, some person. But heavy use of design patterns will destroy the system. So it will reduce the readability. And next one is beware of optimization. So what is known as optimization? Optimization is, in order to achieve the performance of the system, we need to reduce time consumption for certain functions. So optimization does not need to do for all the functions in the system, because there are certain functionalities that are not being used by large number of people. So there could be a particular page which is being accessed by 1-2 people. So you don't need to go and find microsecond level performance for that kind of feature. So that time you can save and invest on other beneficial requirement implementation for a particular customer. And next one is favor composition over inheritance. So composition is more, it is more loosely coupled way rather than using inheritance. So that is the main difference in there. So final one is integration operation segregation principle. So that is like when you have a deep hierarchy of classes, like we have a higher level 1 class, and you have a second inherited one, third inheritance, fourth inheritance, like you will have a very lengthy class hierarchy. In that kind of class hierarchy, so it is very difficult to implement automated testing features, because it is very difficult to isolate each and every functionality in that particular nature. The other thing is maintainability is very difficult, because in the hierarchy it is referring to each and every level upwards or downwards when executing a particular set of functionality. So it is very difficult to isolate functionalities. Right, so those are the principles in the first level. And there are a set of practices also. So practices are the follow the scout rule. So what is scout rule? Scout rule is leave the code better than it was found. So when you are going in, when you are going to do a particular modification, so the code will look like a particular way. But after you do the change, code should be more cleaner than it was. You can't make it worst. So that is a basic idea in there. And secondly, the root cause analysis. When you find a particular bug, it is really required to deep dive into the issue and isolate what is the root cause in there, rather than just doing Googling and find what is the reason for that and just say it. It is not the way. It has to be deep dive and find the root cause. And the other one is use of version controlling system. I think you know what is a version controlling system. So what are the version controlling systems that we do have in these days? JIT and subversion. JIT is a distributed version controlling system. Subversion is a centralized one. So we can, in multi-developer development nature, we can use a version controlling system mainly to, mainly we can use branches, tags, and we have trunk kind of folder structure in there. So that basically used to, we mainly have rollback and roll forward. That means if something goes wrong, we have a backup of previous code base, and we have roll versioning of different things that developers has done. So that is one advantage. And apply simple refactorization patterns. That is mainly to change the internal structure of the system without affecting external behavior of the system. There are different patterns available when we are refactoring a particular system. So it is advised to use very simple refactoring pattern at the level 1. So we are still in level 1. And finally, the daily reflection. So anybody have experience in Scrum, Agile? So do we have a daily reflection in there? So in Scrum, we have a daily stand-up. So that is mainly to share the views, share the work that has been conducted by each and every team member in the previous day. So that is mainly a kind of a information sharing session. So that is one practice, good practice that could be conducted. And level 2, the focus of the level 2 is, it is mainly applying some basic principles of code. Main focus is on increasing productivity and automation of things. So there are main 4 principles in there. First one is single level of abstraction. So What does that mean? If you work with MVC framework, we have 3 layers in there: model, view, and control. So each and every layer has its own abstraction, right? So in model layer, we don't do controlling things. So it is separated. So that is called single level of abstraction. And secondly, single responsibility principle. So that means one class should have only one reason to change. You cannot have multiple reasons to change a particular class. So class, it is applicable for method as well. So that is single responsibility. Third one is separation of concern. So what is a concern? Concern is known as a particular unique behavior of a particular system. So those unique behaviors should be clearly separated. It is something like when we are developing system, we identify modules like payment module and application module, likewise different modules. So that is as that behavior we can identify as separation of concern. Finally, we can use source code conventions. Like when we are reading source code, it should be clearly identifiable. So what has been done in that particular code. So to achieve that, what people can do is can use a naming convention. The other thing is use of comments. When you're using comment should not be very lengthy. You can't write comment like essay, so it is very difficult to read, and it should not be very shorter. That does not give the idea. So it should be used wisely. And in level 2, there are set of practices. So it basically uses of issue tracking. So what are the software available for tracking issues in organizations normally use? Have you heard Jira? Atlassian, Jira. What else? Bugzilla, Mantis, those kind of applications are available to track the issues. So what is the advantage of tracking those? Why people are tracking them? Advantage is to classify bugs, because there could be same bug coming again and again. So we don't need to revisit the same thing again and again. So the main major advantage is they can classify the issues. The other one is communication. So when one person has fixed it, so he can update that has been fixed. So secondly, automated integration testing. So why the integration testing is required to automate? So in testing, what is identified as regression? Regression is when we are doing a particular change, we need to make sure the previous functionality has to be as it is. It cannot be impacted. So if the when we are doing a particular change, if the system has 100 scenarios, 100 flows in your system, so in order to ensure all the 100 are working fine, you need to check all the 100. So but doing that manually is very difficult task. So without doing that, what you can do is you can automate it. So that is called automated integration test. It saves time a lot. And third thing, reading. That means reading educates. Finally, reviews. Reviews in the sense when one particular does a change and there are two people who just need to walk through the code and identify whether there are any better things or he has done anything wrong. So that is level 2 practices. So in level 3, this is all about automation. In the initiative, they talk about automation, and the smallest possible unit should be tested, not just functional things. And there are main 5 principles over there. First one is interface segregation principle. So that main idea is like that. We don't need to extend interfaces that we don't use. You may have seen, if we extend a particular interface that we don't need, there will be plenty of other methods we need to implement. So we will need to put throw unsupported exception within those methods. That means blank methods in our code without any implementation. So that is not pointless. And second one is dependency inversion principle. That is, high-level modules should not depend on low-level modules. Both should depend on abstractions. That means when you have a particular dependency with high-level abstraction, then you need to develop two different components which are abstracting on one particular abstraction layer. That means as in simple words, abstraction should not depend on the details, but the details should be depend on abstraction. It's the other way. And third one is Liskov substitution principle. So those are the parts of solid. There's a design principle called solid. So in solid has main set of things. So that is one of them. So when you derive a particular type from a particular given type, so the type should be substitution of the base type. So that is the idea behind that. For example, it is discussed in example of a duck. So if we take a real duck and the battery operated one, so when making a sound, the real duck will make a real sound. The battery one will need batteries to make the sound. So that is the difference. And fourth one is principle of least astonishment. That is a result of performing some operation should be obvious, consistent, and predictable based upon the name of the operation. So same result has to be given all the time. Final principle is the information hiding principle. So it is mainly if code A doesn't really need to know something about how the code chunk B does, so that communication has not to be done. But the information hiding and encapsulation are two different things. Those are not same, right? So information hiding is a principle, but encapsulation is a programmatic concept. And there are a couple of practices in level 3. First one is automated unit testing. Unit testing could be automated. Secondly, mockups. That means you need to create a mock objects to do testing. And code coverage analysis. That means you need to ensure your unit test cases covers how much of coding in your system. Coding in the sense how much of flows in the system. And then participation in specialist event. That is to get to know about the information. Finally, complex refactorizations. As you in level 3, as I said, refactoring patterns are there. So you can use complex patterns as in level 3. So going into level 4, this is simply the key to productivity and responsiveness. Only when a maximum of many activities in the software development are automated, the CCD would concentrate on the essentials which they implement the customer requirements. So let's see what are the principles in there. There are main 3 principles. First one is open-close principle, right? So what is open-close principle? When you write a particular functionality, method or class, it should be open for extension, not for modification. It should be open for modification. It should be closed for, it should be open for extensions. It should be closed for modification. So that is the nature of open-close principle. Why it is like that? What will happen if you do a change in existing code? It will impact to others. To stop that thing, what you can do is you can extend it and implement the other functionality. And the other one is tell, don't ask. So you can't check the object state, and based on that you can't execute anything. That means you don't need to depend on the state of the object, right? So that is called tell, don't ask. It should not be making decisions based on the state of the called object. And third one is law of Demeter. That means when you have dependency on, let's say, more objects, so if one of the object fails, what will happen? Your object, your calling object will be failing. So that is the idea behind the law of Demeter. So those are the practices in there. We have continuous integration. So what are the tools available to implement continuous integration? CI? Any tool that you have used? Jenkins? Have anyone used? Okay, so there are tools to automate. So the purpose of tool is to, like Jenkins will be, when you give a particular subversion code location, so Jenkins will be building the application and it will be creating the WO file. So it will be executing unit test cases. It will be doing code analysis like SonarQube and security analysis kind of things. And finally, it will be uploaded the file into a particular common location. So your production deployment and everything will be happening from that particular location. So that is one purpose of CI tool. And static code analysis, like we have tools like SonarQube. So what they will do is when you give the SVN location, so it will analyze your code. It will say this method is not standard. So method size is very lengthy, comments are not enough, and there will be unimplemented method. Those kind of things will be alerted. And inversion of control container. So that is one part of Spring framework in Java. So when it is not hardwired, it is very easy to do the configuration, easy to manage it through configuration. And finally, the experience and measuring errors. So those are the practices that could be followed. And in level 5, there are 3 things. Design and implementation should not overlap. So when you are designing a particular application, designing and implementation cannot be done at the same time, because design has to be finalized first, and then only you can start implementation. Right? But even in Scrum Agile environment, that has to be same. That in a particular sprint, before start implementation within the sprint, the objective has to be designed first. Thereafter, you can go with the implementation. And implementation should reflect design. That means once after you do it, it has to be the design. And finally, you ain't gonna need it. That means there are a lot of functionalities that does not add business value. So those things are not being developed in usual development environments. So that is taken as a part of backlogs and also all those things in Scrum, if you know it. But just keep in mind. And those are the practices in there. Continuous delivery, so it is a part of continuous integration. And iterative development. So what is iterative development? So if we have very lengthy task to do, what we will do? We will break it into smaller parts and then develop it according to that. But the smaller part has to be a particular objective. It should be deployable. You just can't develop backend part once and front end part once. So that is not the iterative. It has to be deployable, production ready one. Component orientation. So as component based architecture, you can develop it. And finally, test first. Customer is the king. So when you are developing a system, you can interfere with the customer always. And finally, it becomes white when all the principles are being achieved in a particular system. So those are the things has to be followed. And finally, after completion, achieving of those principles, there are main 5 virtues are being achieved as per this initiative. First one is treasure variation. That means variation of values that are being exercised. That means system has a value always, but you can change those values since the maintainability is in there in the system when you achieve all those 7 degrees that we have discussed sometimes earlier. And do only the essentials. So it says when those degrees are being achieved, so you can do only the essentials. and isolate aspects. Different aspects could be separately isolated, and minimize the dependency. Dependency of the each interacted components can be reduced, and then hold promise. You can deliver the customer what you have promised. So that is the main idea behind that particular framework. Cool. Right. Any questions on that? All right. Then thank you very much.